We are live. Okay, we can say hi to Finna. Hi, Finna.
Hi, Finna.
There you go. All right, we are live. So our objective today is factoring polynomials. What the heck is factoring? Well, let me show you an example. It is undoing the distributive property or undoing FOIL. It is undoing either the distributive property or undoing FOIL. Okay, I'll show you. Example 1 really used to be this. Okay, example 1 really used to be that. The original problem used to be 3 times x plus 2. So if that was the case, you can see that you can go 3x plus 6. Everybody get that? Thumbs up?
Yeah.
So what we want to do in our example is make it look like that again. So we call it common factoring. So what I have, the original problem is this. Here's how you do it. It's called common. Write down common factoring because we're looking for what's in common. So we're looking for common factoring.
No.
So what do they have in common? Example 1. What do they have in common? They have a multiple of, what do they have in common? Multiple of 3. Or here's another way to ask it. What is the biggest number that divides the both? 3. So the common multiple is 3. Okay, let's say it again. What's the biggest number that divides into both? 3. So that means the biggest multiple would be 3. So they have a common multiple of 3. Let's write it down. Let's write it down. So they have a common multiple of 3. I write it down. And then I need to find out if I factor out a 3, I would have a 1x plus 2. Because 3 goes into 3 one time, 3 goes into 6 two times. And you can even check by just, if you wanted to check your work. You can just multiply it back out. Will it make the original problem? Yeah.
Is it the smallest number that goes into both?
Biggest.
Biggest number.
You want to completely factor. And that's a great question, Sean. So Sean just asked a great question. Easy way to explain is this. If I have 4/8 as a fraction, you would not stop at 2/4, would you? No. You would reduce it completely. You want to factor out the biggest multiple. Okay, does that make sense? Good question. How about example 2? What do they have in common? 4. Okay, 4 is correct. But they have more.
2.
Yeah, there we go. They have a 4 in common, and they also both have a x. Don't they both have an x?
But the biggest one would be 4.
4 is the biggest multiple, yes. 4 goes in, yes. And they both have an x in common, okay? So they both have an x. I common factor out the x. They both have a multiple of 4. Now, if I take a 4x out of the first term, I would just be left with a 1y.
Wait, you can't do that though because 4 times,
It's bed?
4
Okay.
times 2.
And then 4 goes into 8 two times, but I already took out its x. Now, if you want to check, you can always multiply back through and make sure that you have the right answer. Because if you multiply back through, it should go back to the original problem. Thumbs up? Am I doing okay? Boy, am I ever glad I did this day. I'm glad I did not move ahead. Example 3, what do you see?
8.
Good, multiple of 8, everybody agree with that? How many x's do they have in common?
Where?
They both have at least how many x's? They both have at least 2 x's. take out as much as you can. When you common factor out the greatest common factor, okay? So that's the greatest common factor. So 8 goes into 16 2 times. I took out x squared. 8 goes into 8 1 time. I took out x squared, so I'd have an x left over. I took out 2 x's, I'd have an x left over.
Could you also do 8x parentheses 2x minus x 2?
Yes, but we want to take out as much as we can. Called the greatest common factor, right?
Okay.
That wouldn't be completely wrong, just halfway done. Take out as much as you can.
Oh, okay, okay. Yeah.
Okay, so if you want to check, you can go that times that times that, okay? How about number 4? What do you see about 4?
5.
Multiple of 5, yes.
Is it going to be x and y?
X and y. They both have a multiple of 5. They have at least an x in common. They at least have an x in common. They have at least a y in common. So out of the first term, I have a 1, x, 5 goes into 5,
2 y.
plus 5 goes into 10 2 times. I took out an x, I have a y left over. Again, if you want to check your answer, you can multiply it through. Okay, real quick before I move on, show me on your hand. Thumbs up, sideways, down. Where are you? I want to see everybody. Right here, diagonal. Right here, right here. Okay, I want to see.
Diagonal and you need a brain break.
That's not bad. No, we can't get to the break. I'm recording. Okay. Right. All right, number 5. What do they all three? What's the biggest multiple in all three?
2.
2. Everybody agree? 2.
2x squared.
How many x's do they all three have in common?
No, 1.
Just 1. Because this one only has 1, right? So you can only take out an x out of all 3 terms. So if I take out an x, so 2 goes into 2 1 time. I took out an x, I'd be left with an x squared. 2 goes into 6 3 times. X goes into x squared x times. 2 goes into 12 6 times, and I took out its x. Okay? Right? And you can check it. Okay, but how about example 6?
I don't know. That's too big of a number.
2, I agree, 2. And then,
See, this is where I'm on.
all right? Now, we learned this as well last year. We learned, now I'm gonna hide the 2 for a second. We learned that last year we could do x times x, positive 6, negative 6. Do you remember that from last year?
Yeah.
X times x, x squared, positive 6, negative 6 makes up positive 36. So completely factored is that. 7. What do they have in common?
3.
3 and what else? Yes, they have a 3 and an x in common. You guys agree with that?
Yes.
3 divides into both. They both have at least an x in common. If I take a 3x out of the first term, what am I left with?
Banana.
X squared? You're getting ahead of me. X squared? Or a 1x squared. You can put the 1 if you want to. Minus, Sean, say it, a 9, right? Now, this one can be done again. This one is very identical to the one we just did. Very closely related to that, right? So could you factor it again? Could you factor it again?
Yes.
What would you factor this into?
3.
Yes?
Minus 3 plus 3.
X plus 3 or x minus 3, either way, it doesn't really matter. Plus 3 minus 3, right? With the 3x out in front. Don't forget the 3x out in front. It is completely factored.
Now I see what
How about 8? What do you see?
2.
And they've got a 2 and an x in common. You guys agree with that? I'd have
X squared.
x squared is correct.
Minus
I agree.
Minus what?
Minus 9.
9?
Now, sometimes we can go further, but the multiples of 9 will not make a 2. The multiples of 9 will not make a 2, so we're done. We're done.
David, do you have a small ruler, like protractor type thing I can use?
You want to borrow? I've got a bunch of rulers. You just want a small one?
Yeah.
Like take a look over there. Yeah, you can borrow whatever's over there, okay? All right, turn the page. Turn the page. All right. Now, trinomials. So let's start first with an easy one. X squared plus, let's go 8x plus 15, okay? Let's go to do an easy one first, okay? So it's a trinomial. So when you factor in a trinomial, we'll start there. But before I go any further, I want to ask you an easy question. Is there anything in common?
No.
So you don't need to do that. Is there anything in common?
No.
So you don't need to do that. So you go to the next thing, okay? We know the only way you can make an x squared is x times x.
Yes.
Right? And then, so x times x goes in the beginning. X times x goes here. And then what times what makes 15? Because that has to go here and here.
5 times 3.
Now why is 5 times 3 such a good combination?
5 plus 3 equals 8. That part's easy.
Good. And then if we need to check it, we can check it. X squared plus 3x plus 5x plus 15. And sure enough, those two terms will make my 8x, right? But now it gets a little bit tricky when you have a number. So with a leading coefficient, that's my leading coefficient. So factoring ax squared plus bx plus c is when there's a number there. Number right there. And it makes it a little bit more difficult. So I'm going to do it two different ways. I want to do it two different ways so you can see the difference. 2xx. Okay, now why did I go 2xx? 2xx. Why did I go 2xx? Has to be 2x squared. Has to be because you have to make a 2x squared. So 2x times x is 2x squared. You guys agree with that?
Yeah.
Now, what goes here and here is the multiples of 5. What times what makes 5?
1 times 5.
Okay, 1 times 5 or 5 times 1. So if I go 1 times 5,
Oh, 2 times 5 plus 1.
where's the 11?
Gotta go on the right side.
Where's the 11? So,
Oh, I get it. You.
2 times 5.
do you remember the double smiley? Or the rainbow, or whatever you guys want to call it. I like to call it the double smiley. Because it's math, right? We should be smiling. Okay, where's the 11? Do you see the double smiley? Where's the 11?
2 times,
Do you see an 11?
and then
10x, 1x, would that make an 11? If that was a positive and a positive, right? Now if I did it wrong, if I did it wrong, if I did it wrong, yeah, if I did it wrong, I could do this. Okay, that's wrong. I still get the 2x squared like Dulce said. I get the 5, but where's the 11? Where's the 11? Do you see an 11?
No.
So that's a 5x, that's a 2x. That one's wrong, correct? I mean, wrong? Okay, slide it up. Example 2.
this one's got to be
So you have to do at least this. Got to go at least 3x x. Dulce, tell them why. Listen to Dulce. Why do you go 3x x? It's got to make 3x squared. You guys agree with that? You have to go 3x x, make 3x squared. You guys agree with that? And now what times what makes 1?
-1 times -1.
Way ahead of me, thank you. 1 and 1. Sean's ahead of us. -1, -1's correct. So Sean, we'll put 1 and 1 in here. And then let's check our double smiley. Okay. I've got a 1x and a 3x. But Sean, you said negative, negative. Why?
Because 3 times negative 1 is that, and then plus the negative 1.
So I'll still get a positive when I multiply negative times negative. I still get a positive. But now I get a negative 1x and a negative 3x, which makes my negative 4.
See, that's the easy part for that, for me at least. But then, like, when you get to complicated numbers where you don't have two multiples that go into each other, that's when it gets hard.
Yeah, it does get harder. Yeah.
That's where I get confused.
No, you're smart. Trial and error sometimes. Okay, now, how about example 3? What are you going to do first? What are you going to do first? Example 3.
2x
2x and
squared.
x. Everybody get that? It's the only way you can get your 2x squared, okay? Now, what times what makes 3?
2.5 times 2. 1.5 times 2.
How about 3 times 1?
That sounds too much.
How about 3 times 1? Okay, how about 3 times 1, okay? So, all right. Or it could be like this. It could be 1 and 3, right? It could be. It could be, right? How do I know which one's right?
By doing that's mine.
Let's check our double smiley, right? Okay. There's a 6x and a 1x. Here's a 3x and a 2x. I need a negative 1x, don't I? Which one of these two can give me a negative 1x? First one. If this were a negative and that were a positive, we could get it, right?
So it's a negative 3 and a positive 1.
Yes. Yes, yes, yes. This one's wrong. Okay, last one. Okay.
3x.
I agree. 3x, x, we agree with that?
No. Yeah.
Now 16. What do you think? Anybody have any ideas on 16? 8 and 2?
Yeah. No.
Yeah.
Wait.
How do I know? Why did I say yeah so fast? 8 and 2.
3 times 8. That's what.
You are getting it. You are starting to see it. 3 times 8 makes what?
I don't remember.
Come on.
24 minus 2 equals
Isn't it
2. Oh, my
close?
lord.
22?
Yes.
3 times 8 is?
24.
And then I can have a 2 here.
Yes. It's negative. That's negative. Subtract.
The gears start. Oh my God, your brains are getting big.
No. I just made an abnormal.
So 8 and 2, not 4 and 4, because this combination here, positive, negative, should make the positive 22, right? And you can check it, right? Okay, that's all we got.